Okay, class. So hopefully you've had some time to practice, and let's just see if you're getting these two questions correct. So again, we have the cube root of 108. I have my little handy list of cubes on the side, so I'm going to put that on the side, and I'm going to ask, okay, well, 108 is right around here. It's right below the 125 mark. So I just go from here and I go up to see which of these four potential numbers is a factor of 108. Now, obviously, 1 is going to be a factor, so we kind of don't even have to look at 1. So my three numbers, the three choices I have, is 64 a factor of 108? You should realize the answer is no. Is 27 a factor of 108? It's very, very interesting, right? Wait, so think about it. 27 times what equals 108, right? Whoa, 27 times 4, what is that? Isn't that 80 plus 28? And you realize 27 is a factor of 108. Is 8 a factor of 108? It looks like it can be because it ends in 8, but actually 108 divided by 8 is not a whole number. It's going to be, I think it's going to be like 13.5 or something like that. So we know that it doesn't work. So we know that 27 is the choice. Okay. Now this is my style of teaching it. Now, what times 27 equals 108? We realize that that is 4, right? Why did I do 27 and 4? Because now this is immediately going to be a whole number. Okay. This is not the only way to do it. Sometimes I'm going to do something that doesn't really look, it's not going to be wise, but I'm going to show it anyways. If you take the cube root of 108, some students will say, well, Mr. Kuo, isn't the cube root of 108 54 times the cube root of 2? And you would say, yes, that is correct. But you have to realize now you have to keep simplifying 54. Obviously, 2 can't be simplified. And you would get this as 27 times 2. And you could keep going with the 27, but you realize, wait a minute. This is a perfect cube already, right? This is a perfect cube. We know that the cube root of 27 is simply just 3. And then you then have to combine the remaining cubes, the cube roots, and you'd say the cube root of 2 times the cube root of 2 is the cube root of 4. And that's your final answer. Okay. Again, I like to use the dot. Typically, they just push the numbers together and just represent it as 1. The dot is also the same. Do you realize this looks nice? This is fairly neat. It's not terrible to do it this way, but if you look at the strategy that I used, when I have the perfect cubes on the side, I immediately know if this number can be simplified, right? 108. There's no reason to just split in half all the time. It's just going to take you more time. So I just think having this list right here is just the faster way to do it. And honestly, to me, it's the easier way to do it. Okay. So then we know that the cube root of 27 is 3. And then this is already simplified. So I'm going to get 3 times cube root of 4. Okay. Let's move a little bit faster. Letter F says the cube root of 128, x6. So this is interesting because when we found the square root of something, we knew to divide the power of the variable by 2. What do you think you're going to have to divide the power by now that we're cube rooting? If you said divide by 3, you are entirely correct. So I'm going to actually split this up into one with the variable and one with the number. So I'm going to deal with the number first. What perfect cube is a factor of 128? So again, I have my little cheat sheet, right? I have all the perfect cubes written down. And 128 is right here. So I know 125 could be potentially an answer, but there's no way because 125 is so close to 128. It's not a factor of 128. right above it, you realize 64 works well with 128. It's perfect. 64, and then the cube root of 2. The cube root of 64 is 4, and that makes us happy. We're pretty much done. So we get here a 4 times cube root of 2. And then the cube root of x to the 6, divide the 6 by 3, you get x squared, right? You're finding how many triplets there are in x6, right? If I had x times x times x times x times x times x, here's one triplet, here's another triplet. There are 2 triplets in x to the 6. Okay, so then your final answer would be 4x squared times cube root of 2. Okay, you can see how this does take up a decent amount of space. Try to be very, very neat. Try to be organized. Math sometimes does require you to be decently organized. Okay, so let's go to the next page. This is page 48. Find the side length of the cube. So the volume is 1029. If the volume is 1029, we're going to have to find the cube root of it. And we're going to cube root both sides. So we cube root the volume, and we realize that that's going to be the side length, right? We learned that in the previous page. So the real question is, what is the cube root of 1029? Okay, so I'm kind of intimidated by that. Like, wow, that's a 4-digit number. Like, how am I going to do that? Well, luckily, we can use a little bit of math knowledge and logic, right? 1029 is all the way over here. There's no way that any of these 3 right here would work, right? Because 512, if you multiplied 512 by 2, you would get 1024. So there's no way that works. 729 is already more than half, so there's no way. 512 was actually more than, no, actually, it was close. It was 512 almost worked. If this was 1024, it would have worked. 1,000 is way too close. What about 343? So this is very interesting because it ends in a 9, and I'm trying to think, what's 343 times 3? What's 343 times 3? So if you don't really know and you're not confident, obviously, class, you still are allowed to use your calculator, right? I like to use mental math, but if you don't feel comfortable and you just want to confirm for sure, 1029 divided by 343 is exactly 3. So it looked familiar too, class, because 343 ends in a 3 and 1029 ends in a 9. And we know that 3 goes into 9. So we've confirmed this is the cube root of 343 times the cube root of 3. Okay, can you imagine if you didn't have this list, how would you even approach 1029? You probably would have divided by 3. You would have to know that 1029 is divisible by 3 in the first place, right? Now, it does look like it's divisible by 3, and hopefully you memorize the divisibility rule of 3, which is if the individual values of the numbers add up to a sum that's divisible by 3, then we know that this entire number is divisible by 3. Okay, so the cube root of 343 is going to be 7, and then this is going to be the cube root of 3, and that's the side length. Don't forget to write, is it units or is it, oh, it's meters. Okay, so we just did the cube root of 1029. At this point, I think if I moved a little too fast, please go ahead and pause, because it's really important that you understand how we even got here. Okay, number 7, go ahead and put a circle. Get this question all the time. I believe I actually discussed this in our office hours the other day. The cube root of 8 plus 64. Is that the cube root of 8 plus the cube root of 64? Okay, so I think the one thing we have to note is every expression under a root is protected by parentheses. Okay, so therefore, if you have the cube root of 8 plus 64, that is equivalent to the cube root of 8 plus 64 written like that. There are invisible parentheses around the expression of 8 plus 64. Okay, you're not allowed to just cut it up and say, oh, I'm going to make the cube root of 8 plus the cube root of 64. No, you have to calculate, you have to calculate 8 plus 64 first as an expression, combine it into one term, and then you take it as that, the cube root of 72. Okay, it's a very, very important concept. Be more than happy to explain that more. A lot of trial and error can go through with this. So yeah, this is just this key right here. Every expression under a root, whether it be a square root or a cube root, is protected by parentheses. Okay, and then now we're going to move into this world, the realm of negatives. Because a cube root is an odd function, we know that negative outputs do in fact exist, right? In the past, when we had a square root, it was an even function, and we knew that a positive times a positive would always be a positive. And we also knew that a negative times a negative would always be a positive as well. However, in a cube root, we know that there's an odd amount of things. So the cube root of -8 actually does exist, right? What times itself 3 times will equal -8? The cube root of -8 is -2, because -2 times -2 times -2, 3 of them total, is -8. However, the square root of -8 does not exist. Cube roots may be negative because cube functions are odd That's it. The potential for an output to be negative does exist for cubes. Okay, so you have to realize the cube root of -216. It's the same thing as a cube root of 216, except you just have to attach the negative. So one way you could think of it is just attach a negative at the end, but we know that the cube root of -216 is indeed -6, right? -6 times -6 times -6 equals -216. Explain in words what happens when taking the cube root of a negative integer. Simply cube root as usual and attach the negative to your value, right? So in this case, 216, we found the cube root of 216 was 6, and then we just attach the negative to each of the values. And since there are 3, you still will get a negative answer, right? A negative times a negative times a negative will indeed equal a negative. Okay, there's going to be a lot of practice in the next few pages, and hopefully this is all making sense. This is part 2, and I'm about to make the 3rd video.